these are my tips for trying to internalize, trying to know the 12 particles that make up the standard model, the fundamental model, which is the language of which physics is based on. If you look at these tables of the standard models, you see it's a lot of particles, it's a lot of information about them, and to try and remember them can be a bit of a daunting task, right? So what I'm going to try and do is give us some tips on how we can try and internalize these, because I'm not a fan of memory. I find remembering things hard. I also think memories are unreliable. They can be a coin flip. And what I want us to try and do is I want us to try and take things we already know, things we've already internalized, in the same way that we know this is a pen. We don't have to remember it's a pen. We know it's the pen. I want us to take things that we know, take things which are already internalized, and use those as anchor points to try and just simply extend those and connect those to new knowledge. So the thing that I want to start with is I want to start with the idea of the proton. Okay, so we're already familiar, at least we should be. This pen's not doing too good. We're already familiar with the idea of a proton. I acquired a better pen. So we're familiar with the idea of a proton. It's something we've probably internalized. We just know. What do we know about it? Well, we know that it has a relative charge of +1. You already know that. That's going to be useful information to try and know these new things. Other things about the proton, which you may or not know, it is a nucleon. Okay, it is a particle which helps make up the nucleus of something, the nucleus of an atom. Now, specifically, the type of nucleon it is something that is known as a baryon. Okay? A baryon is a special type of nucleon, a special type of particle, which has a conserved physical quantity to it. Okay? So, we've already established that the proton has a charge of 1, and that is something that it does not lose. That is a conserved quantity which will carry on between interactions. It's not going to be created or destroyed. And also this baryonness of the proton, this baryon physical quantity that all baryons have, is also something that's conserved in interactions. There's a certain amount of baryonness in the universe, and it's not being created or destroyed, it's being transferred, much like any other conservation quantity we know. Charge, we have momentum conserved in interactions, we have the conservation of mass energy, we also have the conservation of baryonness. So here we have two quantities of the baryon. Now let's go a little bit into the electron. So the electron, we already know about that. The electron has a charge of -1. We can think about how much of a baryon it is. It is not a baryon. So we quantify that. We say it has a baryon number of 0. And that baryon number of 0 is going to be conserved in interactions, right? It's not something that's known as a baryon, it's something that is known as a lepton. And we can quantify that as saying it is a lepton. It has a leptonness to it, and that leptonness is conserved. So the electron's got a charge of -1, it's not a baryon, and it is a lepton. We can go back to the proton over here, and we can add in that fact. We can add in the fact that the proton is not a lepton. It has a lepton number of 0. Okay? So we've established two particles that we already know. And all that we've added on of new information is we've added on that protons are a type of particle called baryon, and that baryonness is conserved. And electrons are a type of particle called leptons, and that leptonness is conserved. And we have quantified those as values for each of our two particles. Okay, so let's keep talking about the baryons. Baryons are specifically made up of 3 smaller particles called quarks. Quarks are particles on the same scale or similar scale as leptons like the electron. So a proton is made up of 3 small particles which are kinda like electrons. Okay? So 3 quarks make up a baryon. A baryon is a nucleon, and an example of a nucleon is a proton, made up of 3 quarks. Okay? Specifically, the 3 quarks that make up the proton are the up quark again, and the down quark. Now the names of these are simply names, and they don't have anything to do with orientation here. Okay? An up, and a down. So what we want to do, at the very minimum, because there's other quantities as well, we want to be able to talk about the charge, the baryon, the lepton, for not just baryons like the protons, but we also want to be able to talk about them for individual quarks that can make up baryons and can make up other particles in different configurations. So let's keep as our anchor point that idea of the proton. So the proton is made up of the up, and down quark. The proton has a charge of 1. The proton is a baryon. It has a baryon number of 1, with a number that is conserved, that baryon-like quality to it, and there's nothing lepton about it. Has a lepton number of 0. So let's try and talk about each of these quarks individually. The up quark, which is represented twice here, has a relative charge of plus 2/3. It is a third of a baryon, so it has a baryon number of 1, and it is not a lepton, so it has a lepton number of 0. It is a third, so it has a baryon number of a third. It is not a lepton, so it has a lepton number of 0. That's what's going on with the up quark. The down quark, knowing this piece of information I've given you here, you might have been able to surmise yourself. I'm sure you have. A down quark has a charge of minus 1/3. Right? Plus 2/3, minus 1/3, overall charge of 1. It is a third of a baryon number of a third. It has nothing lepton about it, lepton number of 0. Okay, so what we've actually done so far is we have established the first particles, the first generation of particles in the Standard Model. Generation 1 of particles. We have the up quark, we have the down quark, and these are our 2 quarks. We have the electron, and this is one of our leptons. The other lepton is known as the electron neutrino. Neutrino, that's Italian, little neutral one, so I'm sure you can derive those quantities very, very easily. It has a charge of 0, neutrino, little neutral one, right? It is not a baryon, there's nothing baryon about it, even in part. Baryon number of 0, no baryon quality to it. And it is certainly a lepton. So that is the generation 1 of our fundamental particles. So it's a generation 2 and 3, which I think I'll save for another little video. But that is the first generation, meaning most stable, of our 12 commonly accepted, widely accepted fundamental particles. The up quark, the down quark, the electron, and the electron neutrino. All about the same sort of scale. What sort of scale? Well, you know this one pretty well. The same sort of scale as an electron. So that's a Roman numeral, that's 1. That is generation 1 of fundamental particles. And they are the various charges, baryon numbers, and lepton numbers for each of them. These two we can derive from the idea of a proton. This we can derive, well, we don't need to, you simply know it. And the electron neutrino, I think the name spells it out for you, neutrino. I like to deliberately think through these facts and derive them each time as I'm trying to internalize them. I'm doing a full repetition, I'm doing a full range of motion. I know that a proton is a baryon. I know it's made up of 3 quarks, so I know quarks have a baryon number of a third. I know a proton has a charge of 1. I know the proton's made of an up, down, so I can surmise from that the up's plus 2/3 and the down is a third. I'm doing these full deliberate repetitions of the thinking in my head because that's how you get to reflexes. You get to reflectionary, regurgitation of your knowledge through these deliberate repetitions. And this is a deliberate repetition to establish knowledge, not to simply establish the memorization of a fact without a context. We're seeing the context of how this applies to anchor points of knowledge we already have. So thinking about it this way, okay, sure, it takes a little bit longer, but it is a lot more deliberate, and over time, you won't have to do this thinking. This thinking will be established and reflexive in your brain. In a future video, we can talk about generation 2 and 3 and simply copy and paste as if we're dragging an Excel spreadsheet across this information we already worked to internalize right here.